Hello. 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 Good morning. Good morning.
Good morning.
Opo, good morning po.
Hi. How are you? Tara mag-zumba muna bago mag-start ng class. Hindi naman nakita mo mga nag-zumba at parang gusto ko mag-join. Sabi ko, hindi. Magkaklase ako. Kailangan, mamimiss ako ng mga student ko pag di ako nagklase. Nice. Pinagpapalit ko kayo sa Zumba. Okay. Picture muna, picture. Good morning. Good morning. Picture muna. Open cam muna, bay. Ay, si Sean, namamaliti pa. 1, 2, 3. Ulit, nagkukusot ko kasi cell. 1, 2. Okay, guys. Thank you. Oh, documents, attendance. Ngayon ay September 6, 20, September 22, number 6. Okay. Kamusta na kayo? Tagal din natin din nagkita. Agad. Anong chika? Meron ba kayong chika dyan bago tayo magsimula ng class? Wala talaga. Lobat pa. Okay. Anyway, for today, we will start with the new lesson, new topic. It is the second method for velocity analysis. We will now have velocity analysis using instantaneous axis of velocity method. But before that, let's have another recap of the resolution and composition method. Gawin ko siyang mabilis. Hindi ko na siya masyadong gagandahan. Sumandal ka. Okay, if we have a mechanism like this one, we will have to start by identifying the points. So we have point A, B, C, and D. Then to compute for the velocities, there should be a given. In this case, the given is the angular speed is rotating at 100 RPM. This is for link QA, having a length of, let's say, 10 mm. Then we have to convert this angular speed into linear speed by solving for the circumference times the angular speed. This 10 mm can serve as a radius because it forms a circle when traveling. So, by computing it, yeah, substitute circumference with 2 pi r, where a radius is our 10 mm, then multiplied by the 300 rpm, revolution per minute. And since one circumference is equivalent to one revolution, we can cancel the revolution unit. We will now have 600 um, pi mm per minute. Then, this is only the velocity. We don't know where the direction is, but we do know that it is connected to point A at link QA, meaning the velocity of this should be perpendicular to link QA. For us to draw how long the vector for velocity A, we must have a velocity scale. So if we have a velocity scale of, for example, we have 3 centimeters per 600 pi mm per minute, we will have to draw 3 centimeters to represent this velocity. Then, once we have that, we will now use this vector as a reference to get the other velocities. So we have to get this to determine the velocity at point B. So to determine the velocity at point B, let's make a line, connect A, B, and C. And make components of the vector. So let's make the perpendicular vector first, the component. Then, once we have this perpendicular, make a vector from point A going to this perpendicular component. Then we'll measure it with our ruler. How long? So let's say it's about 4.2. We will copy it to point B. Let's say this is 4.2. Then we'll make a perpendicular component. So since this is a direction is going to the left, we will make a perpendicular component going to the left. To the left, to the left. Then let's determine the direction of velocity B. Point B is at a slider, meaning its direction should be parallel to the ground. If we have the ground here, meaning the direction of velocity B should be also horizontal, going again to the left because the direction of the components is going to the left. Then the intersection of the perpendicular component and the direction of our velocity B will be the end of velocity B, the vector. Then we will have to measure with our ruler how long velocity b is. This is 1, 2, 3, 4, 4.85. So velocity b is 4.85 centimeters. Then we'll just have to multiply by kv to determine the actual velocity. Next is for velocity c. Again, for velocity c, we can copy the component we made earlier at point A because A, B, and C are all on the same link. 1, 2, 3, 4. 4.2. Let's just copy it here. There. So this is the component. Again, so this is the component from velocity A is copied to B, and this is also copied to C because they are all on the same link. Now let's make the perpendicular component. Again, we know that the perpendicular component is going to the left because the mechanism's movement is going to the left. We don't know the direction of C because it is not given. We cannot use the perpendicular to the link because it is not pivoted to the ground. We cannot use the slider that is parallel to the ground because point C is not in a slider. So we will use a proportionality line. So to use the proportionality line, we connect the arrowheads of the vectors on the same link. So since point A and point B are on the same link, we can connect their arrowheads and we can assume that the arrowhead of vector C is also on the proportionality line because they are on the same link. Then the intersection of the perpendicular component and the proportionality line will be the end of our vector C. Wait, asin na nga natin ito magulo sa baba. Okay. Then, we make the vector of C going to the intersection, and this will now be velocity C. We will measure it with the ruler. 1, 2, 3, 4, 5, 6, 6.6. So if we have velocity C is equal to 6.6 centimeters, let's just multiply it with the velocity scale. We will now have the value of velocity C. Last, for velocity D, we cannot use the components of A on D because A and D are not on the same link. What we can do is use the vector of C as a reference to determine velocity D because C and D are on the same link. The first step is to make a line connecting points C and D. Then we will make new components for velocity C for use with point D. This is the perpendicular component. Then we'll make the uh, along the line component. Then we'll measure this along the line, which is around 1, 2, 3, 4 centimeters, and we will copy it to point D. So to copy it, let's make a 4 centimeters here. So this is 4 centimeters. Then, make a perpendicular component. We now have the components of velocity D. Velocity D is on a slider, meaning its direction is parallel to the ground. If we have the ground here at vertical, let's make a vertical slider going to here. And their intersection here will be the end of velocity D. Again, this is parallel to the ground because this is a slider. Then, once we have velocity D, we will measure using a ruler. 1, 2, 3, 4.1. So, around 4.1. So, if we have velocity D is equal to 4.1 centimeter, we'll just multiply it with the velocity scale. We will now have velocity D. Okay? So, velocity A can be taken by computation. So, this is velocity A, 600 pi. Then, using the velocity scale, we can determine the other velocities. We determine velocity B, velocity C, and velocity D. So this is resolution and composition method. Now, we will be going to the next method, which is the instantaneous axis of velocity method. For the instantaneous axis of velocity method, what we need to remember here is the term axis. What does axis mean? When we say axis, it is the reference point of a movement. So in our design plate number 1, I already used this term for the slider, meaning the axis of the slider is the path where the slider acts on. Just like this one. In our design plate number 1, I described where the axis of the slider is, so you know where to place the slider. Just like this is sliding motion. But for this topic, the instantaneous axis of velocity, we will work on the principles of the axis as a point of reference for the rotation motion. So in simpler terms, the axis of a rotating equipment, of a rotating machine part, is the center of it. What is an instantaneous axis of velocity? Morning. Here, if this link, 12 inches, is rotating or moving, if this link is moving and it is pivoted at point A, meaning the axis of this link is at point A. If this link is moving, this CD link is moving, and it is pivoted at point D, meaning point D is the axis. So in this method, I highly suggest that we use compass. So on our midterm exam, we will have this again, this example solving, and it would be best if you will have a compass. Magkano lang ba compass? Mura lang yun ba? So why would we need a compass? So for example, this link, this body, if we have an axis or pivot at Q, and the given is velocity A at point A, and the only given is point B, we can determine velocity B using velocity A using the principles of similar triangles. So what we need to do, if we will be using a compass, is place the pointed end at Q, then the pencil end at A. Then we will just make point A travel to a line that is collinear with B. So let's make a line Q going to B. Then let's make a path where A will travel to this line. And once we have traveled, this point will now be point A also. Then if this is also point A, we will just copy the vector connected to this point A. And once it is copied, let's make a triangle from Q going to the end of the vector. Then what you can see here is, just like in the principle I discussed in the solution and composition method, the vector of VA is perpendicular to this line. So meaning the vector of A is also perpendicular here. So meaning the vector of B should also be perpendicular to this line. So once we have this triangle, we'll just make a perpendicular line from point B going to this triangle, and now we have velocity B. So this is a faster method than resolution and composition method. So for the resolution and composition method, we resolved the vector into two components, then applied the components to the other points, then make another resultant with those components. But for this one, resolution and instantaneous axis of velocity method, the axis should be the center of movement or the pivot. Then we'll just make similar triangles using the 2 points and using the vector as reference. So I'll make a better example later. So for this one, this is the comparison of the two methods. So if we will use resolution and composition method, we will have this computation. We will have the axis at A, so the vector is perpendicular to link 2. Then the vector of velocity C is perpendicular to link 4. Then we will resolve its components here. This component, then apply it to C. So that is resolution and composition method. But for instantaneous axis of velocity method, we will make an instantaneous axis. In this case, this is Q3. And using this instantaneous axis, we can make similar triangles. So for this, let's make, the given is vector A, and it is perpendicular to this line connecting to Q3. Then we can travel this point A to the line of Q3 and C. So the intersection, this will also be point A. Then from Q3, let's copy first the vector here at point A. For example, this is the vector. Then let's make a line from Q3 going to the end of the vector. Then let's make a perpendicular line from point C going to this proportionality line. And we will have similar triangles, and now we already have velocity C. Okay, I will make a detailed demonstration later. So in the case of rotating equipment, we will have to assume that the contact of the rotating body with the ground will be the instantaneous axis. Then, if we have a given of velocity A, this should be perpendicular to the line going to the axis. Let's make another line from Q going to the point B. Then let's project this point A here. Let's copy the vector, which is perpendicular, this one. Then let's make a triangle from Q passing through A going to B. And now let's just trace from point B going to this similar triangle proportionality line. We already have velocity B. So if we will use resolution and composition method, we will determine the components. But since we are using instantaneous axis of velocity method, we won't need any more resolution for components. Okay, so let's go to the actual demo. How do we do it? Let's use the same figure as yesterday for you to see that for any method, the results will be the same. Alright, so let's use the same figure but now using a different method on computation. So let's say QA is rotating at QA is rotating at 100 RPM, which is moving counterclockwise, having a length of 10 mm. If this is the case, let's compute for velocity at A using this given. So velocity at A is equal to 2 pi r, the circumference, where radius is 10 mm. Then let's multiply with the velocity scale. I mean the angular speed, 100 revolution per minute. One circumference is equivalent to one revolution. We can cancel the unit. Then we will have the velocity A at 2000 pi mm per minute. Let's set a velocity scale. Let's say that for every 2000 pi mm per minute, we will have 3 centimeters in vector. So that's the velocity scale. So if we will apply this velocity scale to the velocity A, meaning velocity A will have a vector of 3 centimeters in length. So let's draw vector velocity A. And this is velocity A, which is 3 centimeters in length. It should be perpendicular. It is going to the left because the motion of the link QA is counterclockwise. Now, how do we first approach the velocities analysis of this using instantaneous axis of velocity? The velocities we have to determine is velocity at point B, velocity at point C, and velocity at point D. Let's first look on if the directions are given. So, for the given, it is not stated to where the velocities are directed to. So, we'll have to apply the principles. For B, since it is in a slider, we know that the velocity at point B is parallel to the ground. We know that it is going to the left because the motion of our crank is counterclockwise. So that's what we know. Then the velocity at D should be parallel to the ground also because it is also on a slider. And we can imagine that velocity D is going downwards because if we imagine this, that the motion of the slider is going to the left, it will be pulling the other slider going down. So we're just imagining right now. So now we know that the direction of velocity B is going to the left, the direction of velocity D is going downwards. How about C? What do we know about C? So we cannot assume yet any direction for velocity C because velocity C is not on a slider, it is also not on a point where it is pivoted to the ground. So we'll just leave it as it is. So now we have determined three directions of velocities out of the four. First is velocity A, then we have velocity B, then velocity D. So for now, these are just directions. So let's solve for the velocity. What we will do now is make the reference line going to the instantaneous axis. So how do we do that? 2 points on the same link, two or more points on the same link have the same instantaneous axis. So meaning, point A and point B and point C, since they are 3 points on the same link, they have the same instantaneous axis. So how do we find this instantaneous axis? We can find the instantaneous axis by making a perpendicular line to the directions of their vectors. So let's make a perpendicular line to this vector VA. I'll just use a broken line to denote this one. Then, since the direction of velocity B is also given, we can make a reference line here. And their intersection will be what we call the instantaneous axis. So their intersection, let's use the instantaneous axis here. Let's make a variable. For this one, let's make Q2 because we already have Q. Okay. Again, let's first determine the instantaneous axis. The instantaneous axis can be found by making perpendicular lines to the directions of the vectors on the same link and making them intersect. So for this one, I made a perpendicular line to vector VA. Then I made a perpendicular to vector VB. And now, these perpendicular lines should now intersect, and their intersection will be our instantaneous axis. Okay. Now what do? We will use the similar triangles. So imagine we have a compass. If we have a compass, let's put the pin on the instantaneous axis and then the pencil end on A. Then if we will trace A, let's make it go to B. This will now be A also. So if you don't have a compass, we can use the ruler method. So by using ruler, we can determine also A. So how do we use the ruler method? Measure the distance of Q and A, Q2 and A. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 centimeters in length. Again, let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is from Q2 going to A. Let's just copy it here. So from Q2, let's make a 9 centimeter length. 1, 2, 3, 4, 5, 6, 7, 8, 9. Meaning, here we have the A. So this one is also 9 centimeters. Just like this one. So we just copied A to the line to make it collinear with B. Okay, so this is, we can use the term projected, copied, anything. So I projected this point A to the line joining the axis and B to make it collinear so we can make the similar triangles. Then, we'll draw the vector of velocity A. We know that the velocity A is 3 centimeters based on the velocity scale. Let's just draw 3 centimeters here. This is now velocity A. So this velocity A is also the same as this one. If we will copy the point A, the vector will come with it. So these are both 3 centimeters in length. Now, if we have this one, we can now make similar triangles from Q, from the instantaneous axis, going to the end of vector A. This yellow line is the proportionality line for the similar triangles. Sure. So it will intersect at the end of vector A, and it will intersect the direction of velocity B. So their intersection will now be the end of velocity B. So once we have that, let's use a ruler. 1, 2, 3.4. So velocity B is equal to 3.4 centimeters. Let's just multiply it with the kV. That for every 3 centimeters, we have 2000 pi mm per minute. Cancel centimeter. You will have 6,800. Tama. Okay. So we now have velocity B. Again, on our midterm exam, we will use whole numbers. You will multiply pi, you will divide by the fraction, then round off to whole numbers. Nakasulat naman yun sa instructions. Yan sabi ko na lang din sa inyo ngayon. So looking at this method, I think this is a faster method than resolution and composition method. It will be more fast, or it will be faster if we will use compass. Okay, now let's go to point C. So what I mentioned earlier, is two or more points on the same link have the same instantaneous axis. So meaning, if the instantaneous axis of point A and point B is Q2, Q2 is also the instantaneous axis of point C. So let's just connect Q2 and point C. Okay, I'll make an imaginary line here. Going to C. Then we will use the same method as we used on point B. So let's just project point A also. Point A, we know that it's 9 centimeters from Q2 going to the C. So it's the same thing. We will make the 9 centimeters also going to the line going to point C. So 1, 2, 3, 4, 5, 6, 7, 8. Wait. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is A. So this is 9 centimeters also. If you have a compass, it is as simple as making an arc or tracing a circle. So it will be easier. But if you will use ruler, you can use this method. Then we will copy the vector again. The vector of velocity A is 3 centimeters long. 1, 2, 3. So this is velocity A. Then we'll make the proportionality line to make similar triangles. From Q, let's make it intersect the end of uh, point A. And once we have this, let's now have it intersect the vector from point C. So from point C, the vector should also be perpendicular because we are making similar triangles. So if this vector of A is perpendicular, then vector of C should also be perpendicular. Kasi natin ito magulo. Okay. Now let's just make a perpendicular vector from point C going to the similar triangle proportionality line. And this should be perpendicular. So now, we now have velocity C. Let's just make it, let's just measure it. Velocity is, C is 1, 2, 3, 4.7. So if velocity C is 4.7 centimeters, let's multiply it with the kV, which is for every 10 centimeter, we have 2000 pi mm per minute. Cancel centimeter, 9,400 mm per minute. Okay? So again, on the exam, lagi ko na lang sinabi, we will use whole numbers only in the velocity analysis, and we will multiply with pi, we will divide by the denominator to determine the velocities. So remember yesterday when we used a proportionality line on the vectors of A, B, and C? So we can check here if it is also applicable, just to see. So if we will use a proportionality line, we will connect point A and B. You will see that it will also connect with C. So meaning, we use a different method but still we get the same output. Nung ginawa ko ito noong una, na-amaze ako eh. Ang cute eh. So anyway, we can see that the proportionality line applies also to this method. Okay, now we go to velocity d. So for velocity d, we cannot use q2 as the instantaneous axis because point D is not on the same link as A, B, and C. We only use q2 on A, B, and C because A, B, and C are on the same link. So how do we determine the velocity at D? So D is on the same link with C, meaning let's find another instantaneous axis for C and D. Okay, so I will repeat. Q2 cannot be used as an instantaneous axis at velocity D because D is not on the same link as A, B, and C. But C and D are on the same link, so we can find another instantaneous axis just for C and D. How do we do that? Given that the direction of velocity D is vertical, let's make a perpendicular line going to that will intersect with the perpendicular line of C. Then C is if we will make a perpendicular line from C, it is already written. Then if we will trace the perpendicular line, it will be intersecting with the perpendicular line from the vector of D. And their intersection, we can label it as the new instantaneous axis, as we can use Q3. So for Q3, we can use the same method we use at A. So first, let's measure the distance of Q3 going to C. So Q3 going to C is 1, 2, 3, 4, 5, 6, 7.4 centimeters. So if it's 7, we can also make 7.4 here. 1, 2, 3, 4, 5, 6, 7.4. Okay, 1, 2, 3, 4, 5, 6, 7.4. Then this will now be point C. So how, again, I will repeat how I did that. Since Q3 is now our instantaneous axis, point C and point D, we will measure the distance from Q3 going to point C. Then, this distance will be projected to the line of Q3 and D so we can make another similar triangles. So Q3 and C is I measured 1, 2, 3, 4, 5, 6, 7.4 centimeter. So let's just put here 7.4. Then I made another 7.4 here. Then we will draw the vector of velocity c. The vector of velocity c is 4.7 centimeters. So let's just draw the vector of velocity c. 1, 2, 3, 4.7. So this is velocity c. Then let's make a proportionality line from Q3 going to the end of velocity c. Then from point D, it will intersect this proportionality line. The intersection will be at this point. So this is now velocity D. Let's just measure velocity D, how long it is. It is 1, 2, around 3 centimeter. So velocity D is equal to 3 centimeter multiplied by the kV, 2000 pi over 3 centimeter. Cancel centimeter, we will have cancel 3, 2000 pi mm per minute. So that's velocity analysis using instantaneous axis of velocity method. Okay, let's have a recap. What's given is the angular speed, the rotation speed of the link QA. It is rotating at 100 RPM. It is turning counterclockwise, having a length of 10 millimeters. Then, we can compute for the velocity of A using this given. That's why we use the circumference times the angular speed to determine the linear speed equivalent. So velocity A. And we now have the 2000 pi per mm per minute. Once we have the velocity, we can now set a velocity scale. So I set the velocity scale that for every 2000 pi mm per minute, we have 3 centimeters in length of vector. Meaning, velocity A should obviously be 3 centimeters. We plotted or we draw the vector of VA because we know that it should be perpendicular to the link that it is connected to. So since VA is here, it is perpendicular to link QA. Then, let's determine the directions of the other points. Point B, we can determine the direction because it is on a slider. It is the direction of its velocity should be parallel to the ground. So we only know the direction. Then at point C, we cannot determine yet what is the direction. Because it is not on a slider, it is also not on a point that is pivoted to the ground. Then at point D, it is also in a slider, so the direction should be parallel to the ground. So okay, again, we just know the directions for now. Then, we will make a perpendicular line to these directions. So in the case of vector VA, we made a perpendicular line, this green intermittent line, going upwards. Then for B, we made an intermittent line that is perpendicular to its direction, going upwards also. Then their intersection will be what we call the instantaneous axis. For this, I denoted it at Q2. So Q2 is now our instantaneous axis. It will be our reference point for this velocity analysis. For instantaneous axis, we can use on actual drawing, we can use a compass. But if we don't have a compass, we can use a ruler method. So for compass, let's just place the pointed end at Q2, then trace the pencil end or ball pen end at A, then make it go to the line of Q2B. But since we don't have a compass, here at my drawing board, I'll use the ruler method. So I measured the length of Q2 and A. It is at 9 centimeter. So I just copied this 9 centimeter to the line of Q2B. And once I copied this 9 centimeter, it will now be point A also. Then we will, if we copied the point A to this line, we will also copy the vector, which is 3 centimeters long. Once we have copied this vector, we will make a similar triangle proportionality just like this one. It will intersect at the end of point A of vector VA, and it will make similar triangles. So once we have the similar triangles, we will make, since the direction of velocity B is already given, it will intersect with this proportionality line, and their intersection will be the end of vector VB. So once we have determined the end, we can now draw the arrowhead, and let's measure the length. And we have determined that velocity B is 3.4 centimeters in length. Let's multiply it with our velocity scale, and now we have the actual velocity of B. So that's P. Next is velocity C. So in instantaneous axis of velocity method, the same points on a same link, two or more points on the same link have the same instantaneous axis. So in this case, point C, we can use Q2 as its instantaneous axis because it is on the same link as A and B. So let's make a perpendicular line also from Q2 going to C. Then again, since for B, I used A as reference, I can also use A as reference for, if you want to use B as reference for C, it is also okay. It will give you the same answer. So again, I copied the point A that is 9 centimeters away from Q2, and I also copied its vector, which is 3 centimeters in length. So once I have copied this vector, I made a proportionality line from the instantaneous axis going to the end of Q of the vector VA. Then once I have made the proportionality line of the similar triangles, I'll just make a perpendicular line here from Q2C going to the proportionality line, and their intersection will be the end of velocity C or the vector of velocity C. So once I have that, I'll just measure it with the ruler. I have determined now that it is 4.7 centimeters length. We'll just multiply it with the velocity scale, and now we have the actual velocity of velocity C. And lastly, for velocity D, for velocity D, we cannot use Q2 as the instantaneous axis because Q2 is used for the points on the same link AB and ABC. But since D is not on the same link with A and B and C and A and B, we cannot use Q2 for D. So let's make a new instantaneous axis. C and D are on the same link, meaning we can make another instantaneous axis for C and D. D is on a slider. We know that the direction of it is parallel to the ground. So let's make a perpendicular line with the direction, and this perpendicular line will intersect at point C. the perpendicular line also, and their intersection will be our new instantaneous axis, which is Q3. Then with Q3, let's make the same method that we used for point A. Let's make point C collinear with Q3D. So that's why I measured Q3 to point C. It is 7.4 centimeters. Then we'll make another 7.4 centimeters here. So from Q3 going to point C. Then if we copied point C, we will copy also its vector. So its vector is this one, BC. And once we copied its vector, which is also perpendicular, we'll make a proportionality line to make similar triangles. And the intersection of the direction of velocity d with this proportionality line will be the velocity d. So since velocity d is now determined, let's measure it with a ruler. It is found out to be 3 centimeters also. So if we multiply it with the velocity scale, we will have 2000 pi mm per minute. Any reaction? Question? After this one, we will have uh, another example before we class dismiss. And if you will compare this with the velocity analysis we did with the resolution and composition method, it will look the same. Okay, so ngayon, medyo na break time muna tayo. Pahinga lang ako ng konti. Resume tayo 8:45. Then kayo, magkain muna kayo or magpahinga din muna kayo. Tapos iwan ko lang naka-open yung screen para tingnan nyo lang yung figure. Baka may maisip kayong tanong. Hello, hello. Ano, may naisip ba kayong itanong dito sa figure natin or sa procedure ng instantaneous axis of velocity method? Hi, hi. Gising na, gising na. Okay, isa pa tayong example. Pagkatapos ng example nito is, sa linggo na ulit. Kasi, again, wala ako sa Sabado eh. Magpapasikat muna ako. So, figure. For this example, we need to determine the velocities at point A, B, C, and D. And if you looking at it, how do we determine A, B, C, and D? If this is instantaneous axis of velocity method, we will have to determine first the directions of the velocities. Okay, so how do we do that? First, let's look at the given. So what is given in this? For example, since we have Q2 and A, B, C, and D, the direction first should be given. So that's Q2A. Oh, ba't di natin taka yun? Q2A, let's say it is 10 centimeters. And it is turning clockwise. So to the right ang kanyang turn. And ang kanyang RPM is 200 RPM. So if this is the given, first let's determine velocity A. The velocity A is can be computed using the circumference times the angular speed, whereas the circumference is computed using 2 pi r, where r can be 10 centimeters. Then n is 200 RPM. But for this example, what if we need to have it in meters per second? To compute, velocity A is 2 pi times 10 centimeters times 200 RPM. The RPM is revolution per minute, and one circumference is equivalent to one revolution. Let's convert it to meters per second. So we know that for every meter, we have 100 centimeters. And for every 1 minute, we have 60 seconds. So let's look at the unit analysis. Cancel revolution, cancel centimeters, cancel minute. We will now have meters per second. So let's look at the example. We have 2 times 200 is 400 times 10 is 4,000 divided by 100 is 40. Then it will be 2/3. Simplest form is equal to 2 over 3 pi meters per second. Calculate ko nga. Double check ba? Sanay na sa mental math eh. So 2 times 10 times 200 divided by 100 divided by 60. 2/3. Okay. So BA is 2/3 pi meters per second. Then to draw velocity A, we will have to determine a velocity scale. So let's say velocity scale is for every 2/3 pi meters per second, we will have 4 centimeters in length ng vector. So meaning, ang VA is equal to 4 centimeters na. Kasi pag multiply natin yan, mag-cancel na yan. Okay. Now we have 2/3 pi meters per second as velocity A. And we have the velocity scale. We can now draw the vector of velocity A. Let's find the direction. Velocity A is perpendicular or with right angle to its link because it is on a pivot. Then, 1, 2, 3, 4.
Nandito po si Ma'am Sol. Si Ma'am Marisol.
Okay, so this is the 4 centimeters. And this should be perpendicular. Yeah. We have velocity A. And now, oh, ba't nag-iba yung sukat? Ulit. Ano ba? Naduduling na ko. 1, 2, 3, 4. Sige. We now have velocity A. Now, let's determine the velocities of B, C, and D using instantaneous axis of velocity method. First, let's look at B, C, D. Points B, C, and D is in a rolling element or rolling link. So you can see that it is on a circular link. Meaning, it is automatic that the instantaneous axis of these 3 points is the one in contact with the ground. So Q4 is already the instantaneous axis. Because points B, C, and D are in a rolling element or a rolling link, and it is in principle in the lecture I mentioned earlier that if we have a rolling link, its contact with the ground will be the instantaneous axis automatically. Q4 now is our instantaneous axis for points B, C, and D. So we cannot use Q4 for point A because point A is not on the same link as points B, C, and D. So this information is crucial for us to know the directions of the velocities B, C, and D. So what we have to do now here is make reference lines connecting the points to the instantaneous axis, just like what we did earlier. So I'll make an intermittent line here, also for C and D. This is very crucial because without these in lines, we don't know the directions of B, C, and D. So now, let's make a B, C, and D. So the directions of the velocities of this B, C, and D should be perpendicular to these reference lines. And we know that the direction of D is going to the right because the movement of our crank is clockwise. We know that C is also going to the right. And we know that B is going to the right also. So, but it should also be perpendicular just like this one and this one. And let's make it perpendicular also here. Yeah. So now we have the directions of B, C, and D. So now that we have these directions of B, C, and D, how do we determine the velocities of B, C, and D? A have already been determined using computation, but for B, C, and D, what is the reference? We just know that the instantaneous axis of B, C, and D is at Q4, but how do we use this information? A and B are on the same link. So this is the link of A and B. Meaning, if they are on the same link, these two, we can have an instantaneous axis. How do they determine the instantaneous axis of A and B? We make a perpendicular line perpendicular to their direction of the vector. I will make a perpendicular line here. This is perpendicular to the vector of B. Then on A, I will also make a perpendicular line. And these lines will intersect. Their intersection will now be the instantaneous axis for point A and B. So let's make it Q3. Okay, again, to determine velocity B, since it is on the same link with link A, we can determine a new instantaneous axis. A and B are on the same link, so we can make a new instantaneous axis just for A and B. I made a perpendicular line with the direction of their vectors, and their intersection will be the instantaneous axis. So once we have this, we can do what we did earlier. Again, if we have a compass, it will be easier. But since I don't have a compass here, I'll just use the ruler method. Let's measure the length of Q3 and A. So Q3 from this one is 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.65. Then let's make this also from to the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.65. So this is point A. Okay, so what I did here is I copied point A to the line collinear with Q3 and B. So this A here on the left side, I just copied it here. It will be easier using a compass. I'll just make a arc going to the line of Q3B, and with since I don't have a compass, I used a ruler instead. I just copied the length here. So 13.65 is this one. And we also have 13.65 on this one. Okay. So since we have copied point A, we can also copy now the vector of point A, which is 4 centimeters length. 1, 2, 3, 4. One, two, three, four. Then this is velocity A. This is 4 centimeters also, just like the vector on the original placement. Then we'll make a proportionality line from the instantaneous axis going to velocity A. Then, since we have the similar triangles, if the vector of velocity A is here and the vector of velocity B is here, we can assume that this is the end of velocity B. So this is now velocity B. Let's measure it in a ruler. So it is 1.3 centimeters. If we have velocity B, it's equal to 1.3 centimeters. You multiply it with the velocity scale, which is for every 4 centimeters, we have 2/3 pi meters per second. Cancel centimeters. We will have, wait, 8/3 times a calculator. 1.3 times 8 divided by 3. So it will be 'Alito na ako, guys. So kung bubuuin natin siya, kaya natin siyang 1.3 times 2 divided by 3 divided by 4 times pi. check nga sa calc niyo kung tama ang sagot ko. Kung gagawin na natin siya, i-multiply na natin yung pi at saka i-divide natin nung sa denominator. Ganito ba yung magiging sagot? Baka mali yung pindot ko sa calc. Okay. Anyway, so we have this velocity b. Then, since we have now velocity b, we can use it as the vector to determine velocity c and d. Velocity c and d, we'll just use the instantaneous axis q4
Extra
and
effort ka pa rin?
copy it to this line. So q4 going to be, how we'll measure it, how long. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.2. And just copy here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.2. So this will now be point B. Then its length is 1.3 centimeters. And this one is, we just copied it here. Then we'll make the proportionality line from the Q going to point, the vector of point B. And once we have this, we will now have vector at D and C and D. So for C, we'll just make a perpendicular line here. And from D, just make a perpendicular line here. Then we'll just measure velocity C is 1 centimeter. Velocity D is 1.7 centimeter. Then we'll multiply it with the velocity scale, which is 2/3 pi meters per second over centimeter. You will have now velocity C and velocity D. I will just share this with you again later. Upload it to Google Classroom. So you will have a reference. On the midterm exam, I will give you a figure and you will just have to determine the velocities using the given method. So I will say what method you will use. So this is instantaneous axis of velocity method. is the challenge here is to determine first the instantaneous axis, which we will use as reference point to make similar triangles, to make uh, projection of points like this one. I projected point A to the other line to make similar triangles. I projected point B to the other line to make similar triangles with C and D, so and so on and so forth. I think this is far more easier than resolution and composition method. You just need a bit of practice to do so. Okay, so that's it for today. We will have our next meeting on Sunday, September 29, as I will not be available on September 28. Again, I will share this also with you on Google Classroom. So that's it for today. Thank you for attending the class. See you again next week.
Thank you po, sir.
Thank you po, sir.